Good morning or afternoon, whenever you're listening to this. So, I know this whole situation is not how we want it to be, but I'm hoping that these videos will be 2-3 minutes each. You can run through them as many times as you need to and get this stuff down. So, let's go and start. This is our first video. It's an intro to logarithms. Specifically, it's 4.2. These whole series of videos here will be 4.2. All right. So, the one thing I want to talk about first is a logarithm and what that is. Now, from Algebra 2, and if you're in pre-calc last year, you should know what these are, but if we don't, let's go and do a quick run through. All right, so I'm going to start this conversation off by asking how to undo, I notice the quotations, certain operations, right? So in this first one, we have x plus 12 equals 24. If I want to solve this, I need to undo the addition with subtraction, right? Because the opposite or the inverse of addition is subtraction. We end up with a solution of x equals 13. All right, and in this next one, we're looking at multiplication with 3 times x equals 24. We undo or redo the inverse of multiplication with division. All right, giving us x equals 8. All right, and then this last one over here of these first three is a square, x squared. If I want to undo a squaring, I could take the square root. All right, and one thing I want to keep in mind is we know how to undo a square because we know what that exponent is. Because what this is bringing us to is when we talk about two operations that undo each other, again, I can add these quotations in here. We call these inverse operations. So this leads us into a logarithm because I can ask how do we undo an exponential here, or what is the inverse of an exponential? And that is going to be a logarithm. Now, I will start saying log because it's a lot easier to say, easier to write. All right, but if I wanted to undo this function, I can take what's called the log base 3 of 3 to the x and the log base 3 of 15, right? Take the log of both sides. It's an operation, just like above we did the addition or the subtraction of both sides. Okay, same idea. Take the log of both sides because what it does is it undoes this first piece. It undoes this 3 to the x, and you just get x equals log base 3 of 15. And that's a number. That's not a great number. We'll be able to figure out how to get a nice approximate answer for that later, but right now, that's a number. Okay, so when I ask what is a logarithmic function, it is simply the inverse of an exponential, or the inverse of an exponent. All right. Now, one thing I really like about inverses is they are practically the same operation, right? If I look about addition and subtraction, those are technically the same operation. Or if I wanted to add 12, I could subtract negative 12. If I want to subtract 13, I could add negative 13. We can convert between what is taking a logarithm and taking an exponent by looking at something with y equals b to the x. Right here, our base is b, and that's equivalent to the log base b of y equals x. Again, base is still b. What changes in here is our input, x, becomes our output of x, and our input or output of y becomes an input of y. All right, one method we're going to use to be able to convert pretty easily to this is what's called the swirl method. All right, it's not the most mathematical, but if I have log base b of x equals y, I can take a swirl starting at my base, swirl around b to the y equals x, right? So I get b to the y equals x. All right, there's not a great swirl for the inverse of that, but what we can do is just kind of, again, keep the base the same, switch the input-output. All right, so what that looks like, so I look at this first one, I can swirl and take 3 squared equals 9, and I get the conversion. Log base 3 of 9 equals 2 is the same thing as saying 3 squared equals 9, which, of course, we know is true. All right, now talking about the reverse, this is where it does get tricky. All right, how I think about it is 2 is our base, so I'm going to have log base 2. All right, my input, what I'm going to be inputting into this logarithm is 16 because it was my output in the original. My output is going to be the input of the original which is 4. So 2 to the 4th equals 16 is equivalent, these are exactly the same statement, as saying log base 2 of 16 equals 4. I was trying to figure out what power am I taking something to get that number. All right, and this last one, again, is in the reverse. I feel like these problems over here traditionally are a little bit easier to do because we have that swirl method to rely on. All right, so looking at switching from exponential form to logarithmic form can be tougher. All right, so I'm going to do the same way I've been doing. It's going to be log base 4. My input is my output. So 64, my output was my input. So 3. All right, so log base 4 of 63 equals 3, which means I take 4 to the 3rd power to get 63. All right, and we can, again, always check by swirling to see if the swirl matches up with what we know. All right, that's all for this first video. Again, it's a little bit longer than I want them to be, but there's a lot of me explaining how this is going to work. All right, so always feel free to watch these videos, try some of the homework problems, and if you don't understand it, come back.